Good day. My name is Selvi. This was my seminar topic, classification and regression trees. Classification and regression are the type of supervised learning. Supervised learning is the machine learning algorithm which learns from labeled data. Classification is about predicting a class or discrete values, example male or female, true or false. Algorithms of classification are decision tree classification, random forest classification, k nearest neighbor. Regression is about predicting a quantity or continuous values. Example salary, age, and price. The algorithms for regression is logistic regression, polynomial regression, support vector machines. Classification by decision trees. Most common and powerful data structure in the whole computer science is the binary tree. The computational cost of making the tree is fairly low, but the cost of using it is even lower. The formula for constructing the binary tree is O log n, where n is the number of data points. The idea of a decision tree is that we break the classification down into a set of choices about each feature in turn, starting at the root base of the tree and propagating down to the leaves where we receive the classification decision. So a tree is made up of it is a set of logical disjunctions if then rules. You can see an example here of the first part of the tree above can be turned into if there is a party then go to it, if there is not a party you have an urgent deadline then study, etc. So here yes and no should be like, it should be yes and no, it should not be in between, so it should be unique. So decision tree algorithms are of three types: Quillen's ID3, C4.5 ID3's extension, and CART. C4.5 ID3's extension uses entropy and information gain for constructing a tree. But the CART, classification and regression in trees, uses Gini Index or Gini impurity. The Gini Index is the impurity in the name suggests that the aim of the decision tree is to have each leaf node of a set of data points that are in the same class so that there are no mismatches. The formula for the Gini index is gk equal to 1 minus summation, where c is the number of classes and I equal to 1 n of I square. All of the training data within it have just one class, in which if we count the number of data points at the node, or better the fraction of the numbers of the data points that belongs to a class I, call it n of I, then it should be 0 for all except one value of I, where c is the number of classes. So by using this we can calculate Gini index, and then for deciding to go on to which branch to go next, to construct which branch we have to do in a tree, then we'll have to go with this formula: g of k equal to summation I equal to 1, c is the class, summation of j not equal to 1, n of I and n of j. By using this we can derive the Gini index as well: g of k equal to 1 minus summation I equal to 1, c is the class, n of I the whole square. Here it shows the regression in trees. Regression in trees, we should make sure that the sum of squares is minimized. That is, we select the values of the nodes which has got minimum sum of square errors. We will calculate the sum of squares for all the data points using the regression formula. In regression, we take the mean of mean average of the nodes. So how we calculate the sum of squares? It is SSR equal to summation I equal to 1 and n y1 vector minus y mean the whole square. So this is the formula for calculating the regression. By using this, we calculate sum of square errors and select the least node which has got the sum of square errors. That is, the value with less sum of square errors is the best for creating a decision tree. Thank you.